Hi Maths fans, welcome back. Back with a Maths Watch clip help, this time for G19, and this is to do with interior angles of irregular and regular polygons. And the one we're looking at here first is standard question 1, and I'm also going to follow this with standard question 3 because they're very closely related here. Okay, so first of all, work out the sum of the interior angles of this irregular octagon. Well, it's irregular, if you might remember this, because all the side lengths are different, have different lengths, and the angles inside, the interior angles, are all of different sizes. And we can see that even without measuring. We can see that that's true. Irregular. Regular would mean that they're all the same. So it would be a standard shaped octagon, something like this. I mean, that's drawn roughly, but you will recognise this from things like tiling patterns on kitchen floors and things like that. So irregular, that's what we're looking at here. Now, it might seem impossible to start off with, but the way to go about this is to use our knowledge that we do have already, which is of angles in a triangle. Angles in a triangle up to 180. So what we do is we choose a vertex, any vertex. I always tend to choose one on the left, and we join it to every other vertex. These are the vertices here. Look, here they are. So I'm just going to show you where they are, and what we're going to do is we're going to join them up. That one's already joined to that one, so then I join it to the next vertex. I move around, I join the same vertex to that vertex, and I keep doing this until the shape here is totally split into triangles. So how many triangles have we got altogether? Let's just number them. 1, 2, 3, 4, 5. We've got 6 triangles. Okay, so let's write this over here. 6 triangles. Now we know that one triangle, okay, has one triangle, the inside angles of a one triangle. So for example, look at this triangle here, would be 180 degrees. And the same with this one, and this one, and this one, and this one. And actually, if you look at it, the angles in this triangle and the angles in this triangle, look, they all make up. We put them together, all these angles of each triangle make up the total of the interior angles of the whole polygon. Poly meaning many, so octagon means 8, agon. Poly, many, agon. Hexagon is 6-agon. So don't get put off by the word poly in this case. Okay, so what are we going back? 6 triangles. Okay, so the sum of the interior angles must be the sum of all of those 6 triangles. Or a quick way to say that is 6 lots of 180 degrees. Okay, 6 times 180, well you can use your calculator for that, but 6 times 100 is 600, 6 times 80 is 480, so I'm getting 1080 degrees, which is quite a lot, isn't it? Okay, and we can use the same process for any polygon that we do. Okay, so that's the first one. We're going to use the same approach in question 3 of the standard here. Okay, so just look at my layout, 6 triangles, sum of interior angles then is 6 times 180. What's different about this question then? This is question 3. In this one it says work out the size of one interior angle of a regular 9-sided shape. Okay, so you could draw it, try and draw one. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not easy to do here. There are little formulas and tricks you can use here, but let's just see if I can get that right. I'm going to check I've got a little sketch there. Remember, yours might look different. It doesn't really matter as long as it's got 9 sides. Let me just check again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, again, I'm going to join the vertices from that one. And how many triangles are we going to get this time? Let's have a look. 1, 2, 3, 4, 5, 6, 7. Now, this is, you see I've drawn an irregular here, haven't I? Okay, so this is true for irregular or irregular. Okay, it's going to be hard for me to draw a regular 9-sided shape. All we need to know with a regular is that the sides, the angles inside will be identical to each other. Let's just do the irregular. Okay, so how many got? 7 triangles. So the sum of the interior angles, inside, will be equal to 7 times 180, because there's 7 triangles there. Okay, 7 times 180, so that's going to give us I'm going to check that. I think it's 1,260. Let's just check. Yep, 1,260 degrees. Now that's all the angles added up together. And this is irregular. Okay, now I'm going to find this hard to draw a regular 9-sided, but we've got to imagine that it all has the same sides. Okay, which means all the angles inside are the same as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I haven't quite done very well. But what we're trying to say is that in a regular one, all these angles will be the same. So what would one of those angles be? So one angle in this case would be 1,260, the whole of them, divided by 9. And that gives us 140 degrees. Okay, that's regular, although it's not drawn accurately as regular, and irregular. The sum inside is the same for both, but if it's regular, we know all of the angles have to be the same, so we can divide by 9. We couldn't do that with this one. Okay, I hope that helps, and I'll see you next time. Okay, bye.